Howdy everyone, Mr. Kaza here with another chemistry lesson, and we're here in my virtual studios in beautiful Atascocita, Texas, and today we're going to talk about writing chemical equations. All excited about that. In this lesson, chemical equations, equation symbols, and writing equations. Now this is a very important skill. Pay attention. Be sure you have all the necessary things. You need a periodic table. You need your polyatomic ions list. Now if you have all these things memorized, that's great. And you must know chemical bonding, chemical names, chemical formulas, oxidation numbers, and the periodic table, or how to use the periodic table. Very important that we get this information down. The chemical equation is a symbolic representation of a chemical reaction, and it reveals three things: the reactants, the products, and the mole ratios, or the amounts. And learning to write a good chemical equation and then balancing it, as we'll do in the next lesson, allows us to understand what we're doing. It allows us to do a lot of things in the future that have to do with chemistry, such as stoichiometry and percent composition, and all these different things are important and based on what we know about chemical equations. Alright, symbols. One important symbol is aqueous, and aqueous just means dissolved in water. But it's important that we understand that. And we use these symbols to tell us what state or in what form the different compounds are. Yield, change, now that is the delta symbol, the Greek letter delta, and we use that to show change. Plus sign means combine. And then of course we have an up arrow to show that it's released. A lot of times we use that to show that the gas wasn't collected, but it was released into the atmosphere. Steps for writing equations. Identify the reactants and products. That's the first thing you need to do. And if you don't know how to do chemical formulas and writing chemical names, then you need to go back, look at those lessons, practice, send me an email, I'll shoot you off some practice sheets, but you've got to know how to identify reactants and products. Then write formulas for everything, both the reactants and the products. 3, place the reactants on the left, place the products on the right, and put an arrow in between them. It's pretty much that easy. And this is easy unless you just don't know how to name compounds and write formulas. But if you can do those two things, the rest of this gets very easy. And make sure you know your periodic table or how to use it, and you have a list of your polyatomic ions. That all these things put together help you to write a better chemical equation. Let's look at an example. Aluminum reacts with phosphoric acid to yield hydrogen gas and aluminum phosphate. Now watch this very carefully, and if you need to, stop and go back, rewind, and look at it again. That's the beauty of video. We have the technology. First, identify the reactants. Second, identify the products. Now write the formulas. There we go.
Hello and welcome to Chemistry Solutions. This tutorial is on balancing chemical equations. In a chemical reaction, atoms are neither created or destroyed, so this means that a chemical equation must have an equal number of each type of atom on both sides of the reaction arrow. We'll start out balancing chemical equations by balancing the elements that occur in only one compound on each side of the equation. Now remember, when balancing chemical equations, you can only change the coefficients in front of the reactants or products in a chemical reaction. You can never change the subscript. If you change the subscript, you're actually changing the identity of the compound. Let's take a look at an example and try balancing this equation. Before we start, we're going to want to take an inventory of how many of each type of atom are on each side of our reaction arrow. So on the reactant side, we have 1 carbon atom, 4 hydrogen atoms, and 2 chlorine atoms. On the product side of our chemical equation, we have 1 carbon atom, 1 hydrogen atom, and 5 chlorine atoms. Now looking at this equation, because we have 1 carbon atom on the reactant side and 1 carbon atom on the product side, carbon is already balanced. So our next step would be to balance the number of hydrogen atoms, and I'm choosing to start with hydrogen because hydrogen occurs in one compound on the reactant side, CH4, and one compound on the product side, HCl. In order to balance the number of hydrogens on the product side, we're going to want to put a 4 coefficient in front of HCl. Remember, we can only add coefficients, we can never change subscripts. Now, if we count up the number of each type of atom we have on both sides, you'll see that we still have 1 carbon atom on both the reactant side and the product side, but now we have 4 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. But by putting a 4 coefficient in front of HCl on our product side, we not only have increased the number of hydrogen atoms on our product side, but we've increased the number of chlorine atoms on our product side as well. So if we look at our new total, we still have 1 carbon atom on our product side, but we now have 4 hydrogen atoms, and we now have 8 total chlorine atoms. 4 from the CCl4 that we had to begin with, and 4 from our 4 molecules of HCl. If we compare the types and numbers of atoms that we have on the reactant side and the product side now, we'll see that we still have 1 carbon atom on each side, we have 4 hydrogen atoms on each side, but on our product side we have 8 chlorine atoms, and on our reactant side we only have 2 chlorine atoms. So in order to balance our chlorine, we're going to add a 4 coefficient in front of our Cl2 molecule. And if we have 4 molecules of Cl2, that now means that we have 8 chlorine atoms on our reactant side. And remember, I chose to add 4 as the coefficient in front of Cl2 because each molecule of Cl2 has 2 chlorine atoms. So if I have 4 molecules of Cl2, that gives me a total of 8 chlorine atoms, which I found just by multiplying 4 times 2. And now that we have the same number of each type of atom on the left side of our reaction arrow and the right side of our reaction arrow, we can consider this reaction correctly balanced. And after you feel that you've correctly balanced your chemical equation, the last thing to check is that your coefficients, which would be a 1 here, we don't typically write, 4, 1, and 4 are in their lowest ratio. Having coefficients that aren't in a lowest ratio does not make the chemical equation incorrect, but typically instructors and classes are looking for the lowest ratio when considering a balanced equation. And typically when balancing your equation using this method, you will come up with the lowest ratio. But it's just one more thing to keep in mind. Let's take a look at another example. Again, I'm going to start by taking inventory of how many of each type of atom I have on the reactant side and the product side. On the reactant side, I have 4 phosphorus atoms, 11 oxygen atoms, 10 from the molecule P4O10, and 1 from the molecule H2O, giving me a total of 11, and 2 hydrogen atoms. On the product side, I have 1 phosphorus atom, 4 oxygen atoms, and 3 hydrogen atoms. Let's start by balancing the number of phosphorus atoms. And again, I'm choosing phosphorus because it occurs in 1 compound on the reactant side and 1 compound on the product side. And it seems to be, if you follow this method, it'll make balancing the reaction a little bit easier. But you can really balance whichever type of atom you prefer first. Because I have 4 phosphorus atoms on my reactant side, I know that I need 4 phosphorus atoms on my product side. And because I can't change the subscripts of any atom, I have to add my 4 as a coefficient in front of the molecule H3PO4. By adding 4 as my coefficient in front of H3PO4, I have not only now changed the number of phosphorus atoms I have, but I've also changed the number of oxygen atoms and hydrogen atoms. So to determine the number of oxygen atoms I now have on the product side, I multiply the coefficient by the subscript on the oxygen, which gives me 16. And to determine the number of hydrogen atoms I have on the product side, I multiply the coefficient by the subscript on the hydrogen, which gives me 12 hydrogen atoms. Now that I've balanced the number of phosphorus atoms on the reactants and product side, I'm going to balance the number of hydrogen atoms next. So using the new number of atoms that I've calculated, I have 12 hydrogen atoms on my product side. In order to give me 12 hydrogen atoms on my reactant side, I know that I'm going to need to add 6 as a coefficient in front of H2O. So 6 times the subscript on H, which is 2, now gives me 12 hydrogen atoms on my reactant side. But again, because I put a coefficient in front of the entire molecule, I've not only changed the number of hydrogens on the reactant side, but I've also changed the number of oxygens. I now have my original 10 oxygens from the compound P4O10, but I have an additional 6 oxygens because I have 6 H2O molecules, which gives me a total of 16. Now you can see in this case, balancing our hydrogen automatically balanced the number of oxygen atoms on the reactants and product side. This isn't always the case. Sometimes you need to go balance that third type of atom, but sometimes you'll be fortunate enough that it will just work out and save you a little less work. And now because I have the same number of each type of atom on the reactant side and the product side, I can consider this reaction correctly balanced. Thanks for listening to Chemistry Solutions.